evening, everyone, and welcome to tonight's lecture, which is the Bruce Museum Presents Under the Skin. My name is Kayla Del Biondo. I'm coordinator of programming and outreach for adults at New Canaan Library. And without further ado, I'd like to introduce tonight's speaker, Gabriela Perez. Gabriela is currently a school programs educator at the Bruce Museum. She received a dual degree in human development and family studies and art history, with a minor in women's, gender, and sexuality studies from the University of Connecticut in 2019. In 2020, Gabriela launched Spanish Digital Bruce Beginnings, a program for Spanish-speaking children ages 3 through 5. Gabriela is interested in welcoming, engaging, inspiring, and empowering all members within local communities through education and outreach programs. Gabriela will pursue a master's degree in museum education at the University of the Arts in the fall of 2021. So thank you so much, Gabriela, for being with us tonight. Take it away.
Of course, thank you. Well, good evening, everyone. Again, my name is Gabriela Perez, and I am an educator at the Bruce Museum. I would like to thank you for joining us this evening for our tour of our virtual exhibition, Under the Skin. Let me just very quickly share with you all my screen. Hopefully everyone can see that. Let me just adjust a few things here. All right. Well, let's jump right on in. If at any point you are unable to hear me or would like for me to repeat myself, please let me know. Under the Skin is an exhibition that highlights the beauty in the biological world through a combination of remarkable imagery and real biological specimens. This exhibition highlights and showcases a dozen recent discoveries from just a decade ago. Under the Skin samples images made possible by an array of technologies such as CT scanning, infrared cameras, and scanning electron microscopes. All of the images presented in the exhibition were captured in the last 5 years, thus representing the cutting edge of modern imagery. Under the Skin highlights various specimens from the Bruce Museum's permanent collection, as well as specimens on loan from other collections. These pieces complement each other, and reinforce the role of museums as stewards of natural history. On our first stop on this virtual tour will be the lifeblood of museums and the importance of museum collections in scientific research. With new technology, collectors can study the historical specimens in ways that early collectors never suspected would be possible. As new technology arises, so does the value of museum collections. And that is because museum collections include specimens that can provide a lot of information about a species. This Guinea shovel-nosed frog is a perfect example of how one small specimen can hold a treasure trove of information. The shovel-nosed frog is a small animal measuring about 3 inches big. And with an animal that small, the question is, how can we study this animal without destroying the specimen? Scientists use a technique called dye CT, which saturated the specimen with iodine and then scanned it with a computed tomography or a CT scanner, allowing the internal parts to be distinguished without destroying the specimen itself. Best of all, the non-invasive scans allow for the animal and its parts to be enlarged and replicated, as we see in the images here. The images shown here represent the different visualizations that can be created from a DICE CT scan. And I would actually like to highlight and bring attention to A, which is the skeleton, to the letter H, which shows the external surface anatomy, I, which shows the muscles and glands, J, the nervous system, and K, the circulatory system. So I'll just give you a few more minutes with this image here. and then we will move on. Technologies and discoveries such as the one we saw help us in learning more about these animals, and additionally, we can take these discoveries and begin the thought process of how they can be applied to humans. With the concept of creating non-invasive testing for specimens, let's move on to clearing and staining. Clearing and staining was developed in 1927, and it is a method used to observe the skeleton with the naked eye without destroying the rest of the specimen. This technique uses a chemical called trypsin to dissolve the soft tissue overlying the skeleton to a transparent state. Then the chemical alkaline blue stains the cartilage blue, and the chemical ulcerin red stains the bone red, which we can see in the image here. Ulcerin fluoresces under certain wavelengths of light, such as UV lights, highlighting the bone structure and providing striking visual imagery. The cleared and stained specimens are then stored in viscous liquid called glycerin. This liquid is so thick that the specimens appear to float, and a single bubble of air can take months to rise to the surface. In the late 19th century, German physicist and mechanical engineer William Rothing developed X-rays. However, the development and use of X-rays have grown significantly since its development. Today, new technology such as computed tomography or CT scans take about 100 X-ray slices together to make a 3D rendering model, which provides more information than a typical 2D depiction. In this image, we have an African clawed frog who swallowed a smaller relative. Cannibalism is rampant in this species and will eat their own eggs and tadpoles even when other food sources are readily available. I should also point out that the specimen we see here on the right is part of the Yale Peabody Museum of Natural History collection, while the CT scan was provided by Dr. Ed Stanley, an expert in frog and reptile evolution. So again, we see here that it swallowed a smaller relative. We then have an eastern hognose snake who was a victim of its own gluttony. This snake swallowed a salamander whole, which we see towards the back here, and attempted to do the same with this toad. The toad, however, lodged in the snake's throat, killing them both. With technology such as this one, scientists can better understand creatures that are too small to be examined under normal circumstances, increasing our knowledge of animals without hurting the specimen. Gaining clarity on early development. Our next stop on this tour, we will be talking about clarity, which is a recent development technique that transforms tissue so that it becomes clear. And that can be labeled with fluorescent antibodies. This allows scientists such as embryologists to study the structure of an animal while they are still microscopic. The brilliant image we see on the right is of a 2-week-old alligator embryo. The fluorescent labeling I mentioned before highlights the nerves green, the muscles orange, and the cell nuclei blue. Interestingly enough, birds and crocodilians are each other's closest living relative. And at this stage, the embryo closely resembles that of a bird embryo, except for the long tail and the nerves that make the snout. So again, the fluorescent labeling highlights the nerves green, the muscles orange, and the cell nuclei blue. This next section is very intriguing, and I believe it's the most intriguing part of our tour, as we will be diving into the topic of fluorescence in animals, which is extremely rare in mammals. However, animals such as the eastern fox squirrels share a genetic mutation that causes their bones to fluoresce a bright pink color when exposed to ultraviolet light. This genetic mutation leaves eastern fox squirrels unable to metabolize an enzyme called uroporphyrin. This substance is toxic in high concentrations, and if built up in humans, it has a dangerous effect, resulting in problems such as sensitivity to light, and in extreme cases, paralysis in humans. This, however, is not the case for eastern fox squirrels, who appear to be immune to those effects. The enzymes build up in their teeth and in their bones, leading them to fluoresce a bright pink color when exposed to ultraviolet light. Additionally, scientists have recently discovered that flying squirrels also fluoresce under ultraviolet light, and unlike the fox squirrels, the pink glow comes from the fur. And here are a few photos of a northern flying squirrel during the day, and next to it, a UV light photo of the same squirrel. It is not yet certain how or why flying squirrels generate their pink glow, but it may help them spot one another in low light winter conditions. And while fluorescent bones are useful to forensic investigators, or in the case of eastern fox squirrels, paleontologists, it was long thought to have no function in the natural world. However, in 2017, scientists reported that some chameleons have thin, transparent scales lying over the bumps on their skulls, which allows the fluorescence of the bone to be seen through the skin. Humans cannot see fluorescence without the proper lighting, but it is likely animals can see under natural circumstances. This ability may be useful in identifying fellow members of their species. And the blue glow is an excellent color, as it is rare to find in a forested environment, enabling them to stand out. So again, here on the right, we have an image of that chameleon with that blue, beautiful blue glow. During this tour, we have focused much on the benefits of UV lighting. However, I would now like to shift our attention to infrared radiation. Infrared radiation is a long-wave part of the electromagnetic spectrum that lies beyond the range of visible light that our eyes can detect. And a great way to view infrared radiations is using infrared imaging in cameras. Infrared cameras record the surface temperature in real time, converting it to an electrical signal that assigns each level a display color. And when looking at infrared images, such as the one we see here, the hottest surface are mapped to the brightest colors. And the image we see here is from the exhibition's thermal camera station with exhibit curator, Dr. Daniel Setka. Regulating body temperature is one of the key challenges that animals face in hot environments. In the case of pelicans, the throat pouch has been co-opted to handle two important tasks. The first one being holding prey, and the second one, shedding heat. The bare skin of the pouch provides a surface towards which blood can be pumped to shed internal body heat by evaporative cooling. We can see from this thermal image, the brightest areas are around the pouch and the bare skin around the eyes. And this is quite interesting when comparing it to the rest of the pelican's body, which we see is radiating far less heat than the areas I just pointed out. New technology not only helps us learn more about current animals, but can also be used in studying long extinct species. In a study published in 2020, paleontologists CT scanned the skull of a dinosaur Mandragosaurus, which we see here on screen. The CT scans revealed teeth that were still waiting below the gum line of the dinosaur's jawbone when the animal died. Here is a CT visualization of those teeth. And again, we see those teeth waiting below the gum line. The paleontologists then cut the teeth into ultra-thin slices and placed them under a microscope. What they found were bands called von Ebner lines, which are microscopic lines that form one per day as the teeth grow. And this is an image of the Mandragosaurus tooth viewed under a microscope. But if we were to zoom in on the image, we see the von Ebner lines, which are indicated by yellow tick marks. And again, using technology such as CT scans allows paleontologists to further learn about the extinct species' diet, their environment, and their growth patterns. Sauropod dinosaurs reached the largest sizes of any land animal, maxing out at 70 tons. That's 140,000 pounds. It's very heavy. Like many other animals, sauropods were born small, yet they would reach their enormous sizes by undergoing a growth spurt during which they could put on more than 1,000 pounds per year. Paleontologists discovered this by using polarized lighting to study thin slices of fossil bone. Polarized light is the type of light wave that passes through a material and splits at different angles, often creating stunning colors and patterns. In the case of fossils, polarized light helps reveal the orientation of fibers in the original bone. Much of the bone in this example shows a fibrolamellar texture and irregular pattern that is created when a bone grows rapidly. These layers were replaced by new and more highly organized bone layers as the dinosaurs grew to better support the stress and size increased. Paleontologists also use CT scans in the form of virtual endocasts to study more in-depth the postures of long extinct species. Virtual endocasts are models of hollow spaces created from CT scan data. And here's an example of a virtual endocast of our Nigersaurus. This virtual endocast allowed scientists to see that the base of the position of a part of the ear canal from the Nigersaurus held their head straight down, picking up plant life on the ground like a lawnmower, which is pretty fascinating. And our last stop on this tour is contrast and cooling. Cloven-hoofed mammals like the pronghorn have a special audio network called the reti inside their skulls that helps keep their brains cooler than their bodies. This cooling adaptation allows pronghorns to conserve water in dry environments. To view this special audio network, scientists use enhanced contrast CT scanning. This technique uses special dyes that absorb X-rays that appear bright in CT scans to map the shape of important arteries or parts of the digestive tract by detecting the dyes as they travel through the body. And over the past decade, modern technology has redefined the way scientists, collectors, and others conduct their research. Additionally, new technology enables historians and collectors to study specimens never suspected would be possible and pave the roads to research breakthroughs, all while creating very striking and stunning images that could be rightfully considered art in their own way. And this concludes our tour.
Thanks, Gabriela. Those were some awesome visuals. Does anyone have any questions in the audience? We have that Q&A feature at the bottom. You can type in your question there. How are these techniques being used to help humans?
Well, that's actually a very good question. And many of these techniques are being used to help humans in various ways. I think the most important one would be helping us humans detect certain issues, for example, in terms of like cancer. So that's how these techniques are being used to help humans. But most importantly, they're allowing us in terms of animals, allowing us to learn more of extinct animals and animals that are in danger as well.
Interesting. We had one other question come in that Q&A area. Someone asked, does anything in the human body fluoresce under UV light?
Not that I know of, no. Because again, that enzyme, if we consume it, it can be very, very dangerous to us.
Sure. And it looks like we had one last question for you. It looks like someone said, what is the biggest animal that they've scanned, and can you scan insects?
That's a good question. I actually do not know the answer to that. However,
all right, if nobody has any other questions, thank you so much, Gabriela.
Of course, thank you
for being with us here tonight and giving us that virtual tour.
Thank you.
All right, I just wanted to wish everyone a good rest of your night, and I wanted to thank you again, Gabriela, for a great presentation.
Of course, thank you. I hope everyone enjoyed today's presentation. Thank you for being here.
All right, thanks. Good night, everyone.
Bye, everyone.